otra cámara. ¿Y cómo cambiaré?
En settings, en cámara, está de arriba.
Ahora sí.
¿Se está cogiendo bien?
Listo. La verdad es que el sonido no sé si...
Eso.
¿Cómo te ha ido? Bien, contenta. Sí, de la universidad. Sí.
Karaoke.
Sí.
300.000 ahora.
200.000. Ni siquiera tiene 200.
Como 150.
Como dice que son 100.000.
Exagerando.
Ay, ¿qué pasó?
Hay dos opciones. Ya está. Hay dos por ahí, ¿no? O hacer una vez o mitad.
Ya también.
¿Qué?
Ya venga un pilotocito también. Lo que es que no hay dos agarra aquí.
En esta silla. Creo que más adelante ya se pueden sentar, pero donde se ganen esta hora adelante. Ah, yo no sé, Juan Camilo.
Siempre estoy chévere. Y de los acordes, estaba buscando
¿Cómo estás?
Qué chévere.
No, no escuchas.
Alejandro,
Diego.
¿Qué? No te hagas. Yo ¿tienes frío? No. Cami. Vamos a ver si logramos que me vea el todo. Es el novio de la alemana. La señora de gafitas de una de las jurados, ¿o qué es? ¿El profe? La que estaba como echando. Es una de las juradas. Son 3. No, son 4. Y otro que va hasta 3 cabezas.
¿Quién otro?
No sé si me había dicho que le decía el lugar. ¿Sabes qué?
Si no,
Pero no quiero. Para que
ordena.
dura.
Sí. ¿Ya la están viendo?
Sí.
Pero no me veo, ¿no? ¿Así me veo?
Sí, ¿puedes ver?
Ah, listo.
Te ves
Perfecto.
la mitad con tu tesis en el computador
Ah, listo.
y el completo.
Porque ya me está viendo Claudia desde Malta. Y
Los
mi
vivos.
amigo William desde Francia.
Bueno,
Entonces, si no me veo, puedes mover la cámara para acá.
sí.
Sí,
Pero yo creo que sí.
qué interesante.
No se mueve.
Antes se mueve por el otro lado.
Dice, llegaron los jurados. Ah, sí.
Can you hear it? Okay, we are already connected.
What is the face?
You already have the presentation, right? Yeah, okay. We maybe we already I'm going to go to Tiberi. Tiberi. Hi.
Okay.
Excuse me. We have some requirements for this kind of Okay.
Okay.
Eso solo pasa con
Okay, perfect. Well, in this case, we can begin.
Don't let me put on my tie and now I'm done. Okay, I'm done. Okay.
Okay. Okay. But maybe the camera will be oriented toward you.
No, este es el.
¿El streaming?
Este es el stream.
Yeah,
The last version of the
Él es el otro lado.
Oops.
Todo.
okay,
Okay, sorry.
no problem.
Okay. All is good.
Okay.
It's very. Yes.
Los formatos. Los formatos. Okay.
La
La presentación no se puede ver bien, pero la resolución.
Buenas tardes ya. Muchas gracias por estar aquí. Esta es la presentación de la tesis doctoral de Juan Camilo Ibarra. I will shift to international English, my English, and slow English. And thank you for your presence and your presence. This is the session of official presentation of the thesis, doctoral thesis of Juan Camilo Ibarra this title. And thank you very much to Frederic Mariette, who is the international advisor of this work, and our international member of the jury, James Collier from Iowa State University.
Podemos compartir, porque no tengo la presentación de compartir la pantalla.
And today
No se puede
will be very soon the president of the jury.
Pero es-
I will, cool. Professor Hans Hagen from Kaiserslautern Technische Universität, from Computer Graphic and Human Computer Interaction team. Thank you very much. He is currently in Arizona, in the United States, and he's with us by Skype. And Isabel Arteaga is a professor from Architecture School from Los Angeles University, and Juan Pablo Bocarejo, professor of Civil and Environmental Engineering here in the University of Los Angeles too. Monsieur le Président, proceed. Someone needed. So you were excuse me. The traditional format is that we will invite Juan Camilo Ibarra to do a presentation of 40 minutes. The flexibility about the time is the president. And after the jury members, of course, are invited to do some questions or comments or suggestions. And the other professor present in the room, if they want, can do some interventions. And we hope to finish in 1 hour, 10 minutes. Maximum. It's all the exceptions are under control of Monsieur le Président. Right?
Yes.
Let's proceed.
Okay. First of all, thank you all for coming here for my thesis defense. My name is Juan Camilo Ibarra. I'm a thesis candidate. My advisor, Professor Rodrigo Hernandez from Universidad de Los Angeles, and Professor Frederic Mariette from Architecture Polytech in France. So I'm going to present to you my thesis work called TaCAT, Task Center Analysis Tools in Urban Planning. So what is it about? The first part is, okay, we have the city, we have the stakeholders that have some concerns about the city, and we want to show them analysis tools, but centered in the urban planning analysis task. That's the sets of questions that the stakeholders have about the city. So what is this? We have the urban planners here, those are the stakeholders. They have some analysis tasks that are set of questions that they have. Using a TaCAT designer, the TaCAT designer with the stakeholders have the analysis task specification. He uses the data sources from the stakeholders and the analysis tools from the stakeholders in order to create these applications. How to make these applications using the TaCAT framework. That is two components, that's called the urban system model and analysis task model. This TaCAT framework creates the application. This application is given to the stakeholders or users that have the same topic, the same concerns about the stakeholders. They make an evaluation of the application, and if it's necessary, they can begin the cycle again to create the application or to use the application. So the scientific contribution of this work, it's a data structure for creation of this kind of application centered in this task. This is a very important thing here. Creating a urban system model to characterize a city. That means to create a city, to create a model of the city. Characterization of analyst tasks. The idea is to see how to use the analyst task, to create this analyst task in order to be useful in the tool. And finally, fast prototyping of this kind of tools. So the agenda of this presentation, first I'm going to talk about the context, a little context about the idea here, the problem that we want to try to solve, the proposal to solve this problem, finally some experimental cases using the framework and the workflow, and finally some conclusions and future work. So first, for the context, I'm going to talk about what is a city and what is urban planning for us. First, what is a city? So a city is a concept that is sometimes difficult to say what is a city itself, because there are different points of views depending on the people that is going to see the city. It could be buildings, it could be the people living in the city, it could be flows that goes through the city, political struggle, mental images. All of these are the same city, but the definition of the city depending on the user that is seeing the city. So depending on the point of view from the stakeholder of the user of the city, they have different representation of the city. For example, perspective models in 3D, maps and plans, simulations, story pictures, so on. So from the beginning, we have a problem in order to define what is a city for us. The next step, okay, we have a city, we want to improve this one in order to the people that live better, have a better quality of lives. And to do that, we have to think about the city. So why is it that we need to think the city? Because modern cities have problems. Albrecht says, okay, they use too many natural resources, they pollute, they destroy ecosystem, they increase social inequality. But the good news is that these problems can be foreseen. It means we can plan ahead in order to resolve these problems. Using what? Using urban planning. So for us, what is urban planning? In the context of this work, we're going to use the Taylor definition, that's the technical and political process, in order to improve the development of communities. Using three main trends. That's the land use, the urban environment, and the transportation networks. And also it's important to note that in this urban planning, the stakeholders are present in this planning process. And for us, what is a stakeholder? Stakeholder is any group of individuals that have specific issues in urban planning, and also that can be affected for those decisions. So if I have a set of stakeholders, if one stakeholder make a decision, his decision can influence the decision of the others. So that's a stakeholders definition for us for this project. So these stakeholders also uses data. There's a lot of data that this project uses, and this kind of data is, for example, static, dynamic, or temporal data. So if this data is the data that's going to be used, a solution should use this kind of data. This static, dynamic, and temporal. And also, we are interested in the analysis tasks. That means the set of questions that the stakeholders have for the city. So that's the urban planning task that we want to solve. So what is the problem here? I'm going to talk about what is the problem, how is it addressed today, like what are hypotheses in order to solve this problem, and the user questions around the problem. So what we have? We have here the stakeholders, we have the analysis task, we have the source data, and we have this task that we have actually here. We have several questions that sometimes are different in topics. For example, one stakeholder is his point of view is about transportation, and the other one is land use. So how they solve the questions? So they have this expert here, and this expert in managing a software tool, for example, GIS or another tool, the software tool. With the use of the software tool, they generate data. This data solve the question, and again, the stakeholders can see the solution of the question. The problem here is that this software, usually they don't talk to each other. So the decisions have to be made from one point of view or from another point of view. The data also generated also cannot talk to each other. So the solutions could be solved in several ways, but if this solution involves something in this solution where this one is not going to see the problems here. So one possible solution is, okay, the stakeholders will not use different software tools to analyze different aspects of the problem, but only one solution, one software solution. The problem here is that the expert, in order to model all of these two questions, for example, is going to need more time, more effort in order to model the solution in one software solution, software tool. And then the data is created, the questions are solved, and the stakeholders will have the solution that they want. So how is all this work is done today? So there are a lot of analysis tools, there are a lot of software tools in order to solve some of the questions that they already have. So for example, the graphical data management, we have GIS system, we have also 3D city models in order to not only to have 2D information about the map, but also information about height or information about the buildings that are inside a city. For example, CTGNL is a word for 3D city models. Also, we have all the visual representation, for example, CAT systems, or a lot of systems that generate information, visual information for the city. And also, we have the process management software tools in order that, to help stakeholders gain information about the decision-making process. For example, the building information models, that's an evolution from the CAT systems in order to create information about a building, or the construction of a building. And the CIM, the city information models, that's also the evolution of the geographic information system. The idea is to have something similar from the building information model, but for cities. Not only for one building, but for the whole city. So, taking into account the problem, how can we help here? This is our hypothesis. The hypothesis is that this creation of task center analysis tools can improve the decision-making process in two main aspects. First, the analysis expressiveness, that means how to visually model the analysis task, the question, in order that the stakeholder can see the question in the visualization and can solve it. And the second one is analysis efficiency. That's having the right tool at the right time. That means that the creation of these applications should be in a fast manner in order to have the tool ready in order to answer the questions from the stakeholder. So to solve this hypothesis, we are going to launch some research questions. The first, how to represent the city, as we see before, it's a problem that we want to solve, how to represent it. And what is analysis task? To define the main point, the core point of the thesis, that's the analysis task. How to integrate data, because we are going to work with different stakeholders, we should be able to integrate data from all of these stakeholders. And finally, how to create analysis tool, how to create this software tool in a fast manner in order to solve the situation. So this is now I'm going to talk about the proposal to solve these research questions. The proposal is called TaCAT, that's analysis tools. I'm going to talk about the urban system model and the analysis model. That's the two main components of the solution that we want to show you. And finally, the TaCAT workflow, that's how to make this kind of complications. So first, okay, we have the questions here, how to represent the city and how to integrate data. We are going to solve it using the urban system model. What is analysis task? We are going to solve it in analysis model. And finally, how to create this kind of applications. We are going to use the TaCAT framework. So, what is the urban system model? The urban system model is a model that is going to model the city in a multi-level structure. Why is that? Because the analysis tasks in urban planning generally are made in different levels. A decision in a local level, for example, for a neighborhood, is not the same if I'm going to make a decision in the city, for example, in the district. So the idea is here that we need to have this multi-level structure in order to model the city. And also, each of these components here have associated data. So for example, one district here have the information about the population, about the income per capita, So we are going to solve this problem using a data graph. That's the information about the data and the data of each of these components in the city. Also, it's important to note that we are not trying to make the whole system again, but to use the analysis tools and the data sources from the stakeholders. So we have these two interfaces in order to use the information generated by these tools that are tools from the stakeholders, for example, to simulate transportation, to simulate some other relations from companies, or for example, statistical information, and also to integrate data sources from the stakeholders. So the multi-level structure is this is one. We have like a pyramid here with different levels that we call level of granularity, and in each of these levels have these red orange circles that represents an urban feature. What is an urban feature? It's a subcomponent from the city that can be tangible or intangible that is going to be inside the city. For example, a building, a street, or for example, a policy. And so all of those are called spatial objects. Why spatial objects? But because they exist inside the city, it's kind of in a position inside the city. There's a relation between these spatial objects. Here, for example, one spatial object in this level have children in the next level. For example, here in one district, in this one, they have another blocks in this district. So these blocks are spatial objects that are children from the spatial object over here. And these are arranged in level of granularity, and also are arranged in groups. These groups are a grouping for spatial objects inside a same level of granularity, for example, to express that some buildings are in the same neighborhood, in the same block. These spatial objects are the representation of these different features, but they also can be from the spatial object, visual objects can be created. These visual objects are the visual representation for the spatial object. For example, why is that? For example, we have a building that I have a lot of information from this building. I can visually depict it in an application in different manners. If I want to use the model of the building, okay, I can show the model of the building, but if I want to show some information about the building, I can use, for example, squares, or I can use a glyph to show the information for the building. That's the visual object. So for each spatial objects, I can have any visual objects related to this spatial object. It's important to know that the creation of this structure depends on the task. So if I want information about one part of the city, I'm not going to create the whole city in the information and in the structure, but only the part of the city that is important for the task. If the task needs, for example, one point and the surroundings are also part of the structure. In order to create that, we have an API to create this USF, to create this Kubernetes model, and an XML definition in order to partially automate the creation of this structure. Next is the data graph. Okay, we have here the structure, and each of these components can have data, associated data for those components. For example, I can say a building, a population, a building, some other information. This data is related to other data, and I have functions, for example, to create or update data. I'm going to talk about more in details later about this. Here it's important to note also the relations for this data is not the same relation of the structure. For example, two spatial objects that belongs to the same group, the data from these spatial objects cannot be related or could be not related. Maybe some data from this spatial object is related to another spatial object in another part of the structure, because the task needs this relation. So that's why the data graph is created here. And like I said, this data graph also can be used for generation of data using functions to create data in upper levels. And that, for example, if I have the city in different levels, I have a local level, a level, a different level. And the analysis task is to analyze the current situation of the space, per inhabitant in Bogota City at different levels. Next is the data graph. Okay, we have here the structure, and each of these components have data associated with those components. For example, I have a building, a population, a business, a building, a population, and the analysis task is to analyze the current situation of the space per inhabitant in Bogota City at different levels. So the problem here is that maybe in this level, in this urban level, all of the districts here don't have the data. So the idea with the data graph is to create this data using the data from a lower level, for example, from a level. Using, for example, average in order to create this data and to complete the information in different levels. Okay, that's the part of the urban system model. The next part is the analysis task model. We already have how to model the city. Now I want to model the analysis task. So the idea here is, okay, I have the task here, I have a set of questions from the stakeholders, and I want to have a visualization in order to see the data and the question from the stakeholder. In order to create that, we have two main components, that's the analysis variables and the analysis task types. There is the content variables, vision variables, and impact indicators. I'm going to talk about this in the next slide. And have observation, evaluation, alternative generation, and alternative assessments. This is the kind of tasks that the framework are going to solve. This kind of task types. So the idea is having the analysis task model using the analysis variables and analysis task types. I have a visualization design step in order to create visualization. How? Using shape mapping, color mapping, geographical views to the widgets for additional information, and create this kind of visualization. So, what are these variables? The foundation variables are those variables that can be controlled by the user and be raised and be altered. I'm going to show you an example of that in the next slide. The content variables are all of those variables that are remainder, but are used in the analysis task. The user cannot change these content variables, they change the vision variables, but some other variables are going to be changed. And the impact indicators are used to compare between two alternatives. The alternatives that are going to be derived from the vision variables are going to be compared using the impact indicators. The impact indicators are the function between the vision variables and the content variables, and these impact indicators are going to be used in order to assess an alternative, to evaluate an alternative. So, for example, we have the task is to analyze the impact of new facilities in the facility. The decision variables are the empty parcels that are changed to facilities. The idea is to how a new facility is going to impact the zone. The content variables are population and current facilities that are going to be changed. And the impact indicators are, for example, the facility coverage, that is a standard that I want to be. This for facility area per population, precision price, and area being used. So it's important to note also that these impact indicators help the stakeholder make a decision, because it's not a problem of maximization or minimization of variables, but it's a subjective solution. Subjectively, the user, the stakeholder is going to choose one of the information that we have. So using these variables, we create a visualization here. Okay, so for example here, the task needs to a global analysis and a local analysis. And here we show the impact indicator that the value coverage, the given price, and the area being used locally and globally. Here, for example, in this zone, this is the information of local analysis. Here, the decision variables must be in the user interface. So, for example, here in this magenta color is all the empty parcels that was changed in order to create new facilities. And the content variables, the current facilities and population, here in this example, we don't need to show it here, but they are important in order to calculate these impact indicators because of the analysis task. The analysis task needs the population and the current facilities in this zone in order to calculate the impact indicators. In this case, the indices that I want to achieve. Next is the analysis task types. As I said before, this is the kind of task that we are going to model using the framework. We have first observation, that's what's more carefully the system statement of the plan. We have some variables of the system. We have a calculating function in order to change these system variables into visual objects using shape mapping, color mapping, or another technique. We have different ranges and for example, focus context visual specifications in order to create these visual objects, in order to see more clearly the variables that are important for the analysis task, and not so much, for example, the content variables. This is the one kind of type. Another kind is evaluation that gives us subjective assessment about the system state. So, for example, here in this kind of type, it's important to show the impact indicator in the visualization. Next, we have the alternative generation, is to create an alternative change in the system state. If we have this kind of analysis task type, then we know that we need an interaction with the decision variables, because we need to change the decision variables in order to create an alternative. And finally, the alternative assessment is to choose between alternatives using a subjective rule. So if we have the list of alternative assessments, we know that the user interface needs to show a tool to compare two alternatives. So as I said before, all of these variables and these inputs for the decision also can use external analysis tools. So how we are going to use those external tools? We have the decision variables and the content variables that are going to, through an interface, are going to behave as inputs for analysis tools. These analysis tools, the outputs are going to update the content variables and are going to create the impact indicators that create different alternatives. These alternatives are shown to the stakeholders, and the stakeholders chooses which alternative is better. Again, this choosing between alternatives is not a maximization for the decision problem, but the decision is subjective. It means depending on the stakeholder, the stakeholder can choose alternative 1, alternative 3, depending on his needs. So the idea is not that the analysis tool can be a stakeholder, for example, artificial intelligence stakeholder, but to help the stakeholder. And finally, how to create this kind of application. So we propose a TaCAT workflow. In the first step, we have an analysis task solicitation that's close work with the stakeholders in order to see the decision variables, the content variables, and the impact indicators for the analysis task, and also all the available data to create this kind of variable, this kind of visualization for these variables. The next step is the creation of the city itself, the urban system model. Depending again on the analysis task, we're going to create the city model and the data graph using the information from the first step. The next step is the creation of the analysis task model. Using the decision variables, the content variables, and the impact indicators, we're going to create the visualization design step, we're going to create the visualization, and also all the additional information that we need. So for example, if we need a bar plot, we need a line plot, a scatter plot, we're going to create it here. Now that we have the city model, the data graph, the visualization design, we can create the application. So the application is created using these components. And finally, we give the application to the stakeholders or the users that have the same concerns about the urban system in an evaluation step. This evaluation step is going to say, okay, the application is good enough in order to solve our problems, or some, for example, decision variables and content variables are needed in order to improve the application, so the cycle can begin again. So, summarizing again, what is the TaCAT task central analysis tool? We have the stakeholders, we have the staff, the problems. We, in the first part of the workflow, with the stakeholders, the TaCAT designer can create the specification of the analysis task. We have the data sources, the analysis tools that we can use. Using the TaCAT framework, we create the urban system model, the city representation. We can create the analysis task model, that's the task representation. And we create the application that we give again to the stakeholders or the users that have the same concern. And they have an evaluation part in order to begin the cycle again if it's not enough, for example, the variable, or use it to solve the problem. So that's where the proposal. And now I'm going to show you some experimental cases using this workflow. First, I'm going to show some preliminary cases. These projects were used also to see which are the requirements for the application. those were created in the first stages of the proposal of the thesis. So they are not, here, for example, we are not going to present some variables, some quantity variables, issue variables, because they weren't existing in that time. But all of these projects were used to create, for example, the main case. We are going to show the unity buffer and the balance project. And some speed projects in order to show you the speed in which we use and we create some applications. So the first one was the Bogotá 21 project. It was made in 2012. The stakeholders were the subgroup from the Andes that were experts in transportation. And the goal was to explore the impact of transit-oriented changes in Bogotá in the next 50 years. So, the task types that we wanted to see was observation only. The idea was to see the impact of highways development in the area of the indices. So, for example, we made some animations in order to show you how the city should grow until 2050 in height in order to create new green spaces in the area of spaces. The impact of urban growth scenarios using or not using green belt. We have in Bogotá here the Bogotá River, and the idea was to preserve or not some part in the north in order to be a green space and how the population will increase in time depending if we use this green space or not, and some other exploration of employment distribution. The development time was 6 months. We made 5 applications, 5 interactive visualization of this work. The evaluation was non-formal. We had feedback from the stakeholders. And the results were the publication of images and videos of this work in this book called Bogotá 21, towards a world-class country metropolis. Using the results of these applications, we knew now some of the requirements for the application. The next one was done in 2014. This is called the lab group from the School of Architecture in the Andes. Here the problem is to analyze the impact of new facilities in Bogotá City. We already have some examples in the slides before. And we made some other analysis task types. Observation, for example, quantity generation, and assessment. The idea was here for observation explore the current status of Bogotá City in terms of facilities. Generation alternatives is the impact of creation of new facilities locally and globally, as I mentioned before. And finally, assess the alternatives, in comparison between those alternatives. So the application, one of the application was this one. We have a hierarchical view in order to see the region variables, the context variables. We have the global analysis, that means the information about the whole zone that we want to study. The local analysis, we choose some zone, and I'm going to show you some information here. And also, in this case, we made some custom visualization of these variables. These kind of visualizations are not standard. We create them, we design them, and we show them, we put them in the visualization. And here, for example, the comparison of 2 alternatives. I have 2 visualizations from the same point of view. One, for example, here in this magenta color is the region variables. That means which of the parcels are going to be used for new facilities. And here are the impact indicators from the 2 of them. So here, for example, we have the price of the land, the position of the land. Here are the indices that we are going to try to improve. Here is globally, and here are the visualization of the area being used and the area needed in order to get to the point, to the standard point that this is going. Here, for example, we can see that these 2 impact indicators are not not so different. But for example, in this case, the price of a position is more in this condition. Here we can see that the decision is not only okay, which is cheaper, but maybe for the decision maker, the position in the area being studied is more important than the price. So the decision is not a technical decision, but a subjective decision. The development time of this tool was 1 year, and we made iterations to achieve the application that is showing here. The iterations were focused in some analysis tasks, sub-analysis tasks. First, for example, determine where are the potential related nodes, identify definite or surplus capabilities, and finally, locate new capabilities. In the last application, we used all of them in order to create this kind of visualization. The evaluation was non-formal, okay? We have positive feedback from the stakeholders. And the idea also for the evaluation is to compare our results with the SDE project results that the Pluralist architecture already have. They present this project in 2009, 2009 with the SDP, the Secretaría de Planificación, that's the planning secretary from the facility, and we already have a study. And we wanted to see if the decision that they made with their own tools are comparable with the decisions that we make using these tools. Okay, those were the two main cases before having the whole structure for the development of tools. This is the main case that we use in order to show the variability and and if the tool is good enough in order to create these kind of visualizations. The project was the population density done for mobility balance project this year we made it. The stakeholders were again the subgroup, the experts in transportation, and the problem was to analyze the mobility patterns of people depending on three variables: the population density, the strata, and the urban form. I'm going to talk about it more later. The analysis types were the observation. We want to see the impact of social strata and mobility patterns. We want to see the impact of population density and mobility patterns. And the evaluation type is to compare mobility patterns and urban form in different social strata. The idea was to choose between two social strata, two sets of the city, two parts of the city, and compare them. This is the user interface, the main user interface. First, a graphical view, where we have the map having a color mapping about how much of the percentage of this kind of urban type is going to be used. For example, green area, street area, objective, and open sky. That's the green area that the sun have. The street area that the sun have. The green footprint is the area that a building have area, and the open sky is the reminder of the area in the zone. So we have this color mapping in order to show the information here in a global level. We have two visualizations here from variables. For example, I can use density, times of transportation, and here we have information about social strata and urban form data. This urban form is this information about how far an area, the percentage of green area, the street area, the building, and the open sky. And with the user interface, we can choose two ranges in order to have this kind of visualization. Now, this visualization is from one range, and we have the same information that we have in the main interface, but only in the zone that we are going to show. The idea of this visualization is to find correlation between these two variables. So the correlation is here calculated. Because maybe in the whole city, for example here, we don't have a correlation between these two variables, the blue and red. But if I choose a zone, maybe there is a correlation. And also the information about urban form and model shape for this range, for this zone that I already choose. The one area, again, the street area, the green area, the street area, the green footprint, and the open sky. And in terms of model share, that's the use of some transportation modes for the people. Public transportation, private transportation, and transport, or non-motorized here in this visualization. And we created this application in 2 weeks using the stakeholders, working alongside with stakeholders. We made 2 iterations for the creation of this application. And the evaluation, we made an evaluation using six expert users, 3 session evaluations, an introduction, an application, and a satisfaction survey. And the evaluation was made in asymptotic type and columns. Here is the asymptotic type. We see some peaks here because these questions, the user needed to choose a range. So we find some problems in the interaction of choosing these ranges. And we can see also here in the error. In this question, there's an error of about 5%. Was because the ranges were not well chosen by the user. And here we have the likelihood scale in order to see how well the users see the applications we do. And the summary of the results was, okay, the classical applications can improve this analysis of data. The interaction is a key point in this kind of applications, as I said before, because, for example, to choose ranges, it was difficult for the user to choose it, so it's important to have an interaction, a good interaction with the data. And also, how can we make these applications so fast? Is because we can characterize these analysis tasks, and this is the designing process. As I said before, depending on the type of analysis task, type, we can guide the design of the application. And finally, I'm going to present to you two screen cases that were software that were made very fast. For example, this one was TaCAT simulation period in 2015. It's the project was again software. The problem was to analyze the trip times by bus, car, and train in the next 3 years in Bogota. They made a simulation about this, and we're going to present the data. The next task was to observation and evaluation. First, to analyze the quantity of automatic trips from each zone, and the relation to compare between two zones. The development time of these two was 10 hours, and this is the result. We have here a graphical view, a 3D graphical view, because the task, the stakeholders wanted a 3D visualization. And we have here the first selection and second selection, yellow and cyan. And we have the information about the number of trips by each of the model forms, the bus, the train, or car. And we have here the difference. Here, for example, is for a bus. So the green color means that the first selection is always higher than the second selection by zero. If it's red, then it's the other way around. And the second sprint case was the banking database in rate. The second was about our banking in Bogota. The point was to analyze the quality of movements from ATMs and some offices in Bogota City in 2015. The next step was observation and evaluation, the analysis of quality of movements for ATM and office per month. And the evaluation was to compare two of these points, ATM to ATM or ATM to office. And the development time was 8 hours. The result was this one. We have a graphical view to locate the ATMs of the offices. The ATMs are the orange one, the orange are the blue ones. And we can choose, for example, the yellow one is the first selection, the cyan one is the second selection. We can see here the information about the quantity of movements, and we can have a filtering of data for type of movements here. So we can choose which kind of information or data I want to see here. We can see it by month, or we can see it by year. The evaluation was non-formal. There were 12 banking experts that came here to Quality Lab. The lab session made in November 21st, 2015. That's 4 hours, and we have a positive feedback. We got some pictures of the session using the application. Okay, and so those were the experimental cases. Finally, as conclusions, first, tax center applications. The creation of these tax center applications are helpful for stakeholders. The stakeholders can see the analysis tax, the variables inside this kind of application. Also, it's important to note that the collaborative work between stakeholders and the designer, the hand-in-hand, is important and assures the application effectiveness. Because if we have the stakeholder side by side with the designer, the stakeholder can see the information and can say, okay, this is what I want. This is what my needs are filled with the application. And next, this representation of this custom city is helpful because with the API and the XML information, I can create the geographical views fast enough, and also the city representation structure fast enough in order to create this kind of application in a fast manner. And also, well, the characterization of the listas. This is the design of this interactive visualization because guide the visualization. The idea is that we have the variables from the listas, we have the task type, and we can guide the design process in order to have. So the scientific contribution finally is okay. We have a data structure for the listas model in the line. We have the city representation center in the listas, and we have the data integration part to integrate the analysis tools and the data sources from the stakeholders. We have the urban model. The urban model is the characterization of this city centered in the analysis task. We have the characterization of analysis task using this kind of variables, the configuration variables, the context variables, and the impact indicators. And finally, we are able to have fast prototyping of analysis tools for one time. As we see before, the two sprint cases, we made it in less than 12 hours, fully functional application. In the future work, we want to improve this work. First, evaluate this kind of workflow using software developers as users, not only with stakeholders, but how any people can create this kind of application. We already have some experiments using some, not only but other users that create their own applications using the workflow. Also, the creation of visual programming languages for USM creation for the urban system model and the application design. We can do that because we already have the main specific language to create this kind of visualization, with special objects, etc. We need to work more in time changing scenarios. That means, for example, a city changes in time, so we need to explore more in depth about this kind of scenarios, how to visualize these kind of scenarios, how to see these changes, and also placing in different domains. The idea of this work also is, okay, we have a hierarchical structure, we have a task that uses this structure, so we can explore in some different domains, for example, in biology or in another domain, in order to create also this kind of applications. So that's it. So if you have questions. Okay, thank you.
So it's my in the US, a lot of times what we do is looking up to the spectators to see if they have any comments or questions. You have a question, all right? I keep so, audience, do any of you have any comments or questions for one of you?
Probably I missed it because but it would be very nice to see a little bit of how you compare your types of results that around. Like my main question is there could be systems that maybe do something similar to what you do, but not in the right way. So I don't know if you can mention something, maybe not as extensive as it.
Yes, we made some tests because we plan to do two kind of tests. One is the use of this kind of applications. One was to create this kind of applications. So from the question is the creation part. For the creation part,
before that, when you start to work, you have to position your work in what's happening right now.
Okay. Yes. So when we begin the work,
You can one back. That I think you missed an opportunity today. I don't want to answer it. I have this question. You said, well, what's a solution? Well, let's just have everybody use one tool. You never said what the problem is. You just said, okay, now we'll move on. So, so what's the problem that say, why don't I just use the GIS and have models that use VIR.
Yes, here, for example, the problem here is that we need an expert in order to create this kind of application. And for example, for GIS, if I want to model, for example, a lot of topics, for example, transportation, simulations, some of those, GIS already have those kind of topics, but we need an expert in order to create these topics. So this expert needs more effort, more time in order to create a whole application to answer all of the questions. And another problem is also that in order to create my task in this kind of application, I need to be able to like model my task in these terms. So if we want to do it the other way around, the application is going to be in terms of the task. So also, for example, in GIS specifically, they already have like a visual programming tool in order to create a lot of information semi-automatically. Say, okay, information from here, information from here, information from here. The problem is in GIS specifically is that in each step I'm going to create new prototype, new set of data. If I change the first one, okay, I have to recalculate everything and again calculate this one. And if I want to do it automatically, I have to create this workflow in this programming tool. And the idea in our case was, okay, what if we can eliminate this expert in order that the stakeholders can create its own applications using their concepts and not and using their language, not have to change their language to the language from the application, but use their own language. Obviously, having the information that we have. Okay, if you have an analysis task, you should have decision variables, content variables, impact indicators. And if you want a city, you need to know in which level of the city you want to work. So in this part, we say, okay, we want to work on that. And in how is that today in the state of the art, we are trying to do something like city information model. The city information model, okay, we want to put everything, any topic in this city information model to create the process. But here the idea is like the whole project. Our idea is only one part of the project. The solutions for this part of the problem, this analysis. I don't know.
Yes, it's just that from the list it's very difficult to ask at what level these guys have developed their ideas and what is your particular contribution to the state of the art. That's maybe what it would be nice to stress.
Okay. Yes.
Is it possible to do your work in another kind of domain, engineering domain, in particular the visualization?
Yes. Actually, that's one of the future work that we want to do, to test it using another domain. We already have the core. It's a structural way. It's not only for city, but it's a structural way. We have a structural, and here I have different levels. If the model I want to have different levels, each of these levels have components that relate to each other in a hierarchical way, and I have analysis tasks for this kind of structure. We can do that. Also here, because we are focused in urban planning, we already have the visualization for maps. So but like you see, we have not only 2D visualization but 3D. So we can explore in different domains using 3D visualization, not only maps but 3D visualization. And also, for example, the interfaces are now. We already have interfaces for geographical data, but we offer a way to create new interfaces for any other kind of data.
Hello, for that. I don't know when I'm about to ask my questions, how is the procedure at your event?
Maybe one or two more questions from the audience, and then we'll turn it over to you, Hans.
Okay, great, thanks a lot.
Sorry.
What kind of source or files you can use?
Okay, now we can connect to shape files, that information from EIS. We can connect to databases, we can connect to MySQL databases. We can connect to SQLite databases. We can connect to Excel files, flat format, CSV, and those are already done. But we offer an interface to create your own transformation tool. If you have your own format, you can create an interface and then you produce the structure and the data from the structure.
Question. What it was not clear, like what was the overall software architecture of the framework? So it was that kind of a web-based application, or it was a client server, or what kind of like software architecture? Yeah, and did you use like off-the-shelf tools or open source tools? How much of the software was written and how much was like reused from different existing components?
Okay, in the question. But in terms of technical point of view, we use open source libraries. We use Java. These are applications, the desktop applications, are not web-based applications. For the information for the graphical information, we use GeoTools as a library for using the graphical information. For the visualization, we made our custom visual application to create this kind of custom visualization for variables. And for the visualization of graphs, here, for example, these graphs, we use a JFree chart. That's another library. So the idea here is, again, depending on the visualization needs for the analyst task, we can look in the libraries. The main core was written in Java. The main core was to create the structure for the city and the structure for the task for the analyst task variables, and the structure for the data graph management, the data. And we can plug, we offer interfaces to plug different analysis tools, we plug different data sources.
Thank you.
I think we need to leave on time. So thank you, audience, for your questions. And Hans, it's good your phone rang. I almost forgot you were there. So why don't you lead off with your question? Oh, he's on the phone. There you go. At least you can see him.
Yes.
Okay.
That's
okay. Who would like to start?
There's no question, but I'm just say some words because I was a people of the team and I want to thank you for your work for the show. I want to thank Tilario with this supervision, this supervision, with challenging times. So, no, I think you had a great job, and especially because the research work was more an exploration issue than on type analysis specifically. And I think as well was the potential contribution of alignment, technological issues, and we developed a tool. We made some use cases with it's interesting
proposing specific users. That's one small question. More related to future works. If you have the possibility to hire some students, and because one main challenge is to make possible the use of this tool in the real context of real users. From your point of view, what would be the possible scientific issue you can propose to these students to study to address this issue, this challenge?
Okay. I mean, I think the main issue should be also to improve the, 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 the process to create this kind of applications, to create this structure, because the main bottleneck is to create this kind of structure, because there are many data sources that they don't talk to each other, they have quality problems, they have a lot of problems. So I think it could be interesting to see if we can improve the automatization or the creation of this kind of structure. That is one. Another one it's possible to create this kind of visualization that web-based in order to show the applications to the whole world, to be really useful, and also to have this kind of interface to create their own applications web-based again, using I don't know, some interaction to create.
Congratulations. Thank you for being here today.
Yeah, to survive this journey.
Yes. So, one of the stakeholders of the project is working together. So we work together in the group, and then afterwards, with the databases and with some of the questions we have. I to understand how the city was involving how people with different backgrounds were improving and using the city. And for us, it was very helpful and very interesting. It gave us a lot of insights and new ideas and new ways to use that. Thank you very much for that. I wanted to make here some comments. So the first one is very similar to yours. It is probably you make your choices when you prepare the presentation. But I initially don't like theoretical background and probably some authors that you have to read in order to build your work. So probably you have to read something about how stakeholders interact. You have to read something on previous tools. So that's one of the things I would like to go even more. So it's basically what was your theoretical start on? And after saying that, what do you think is the step ahead you make? And it's very similar to what was asked before. It's really trying to be more specific on why your tool is more advanced, more useful, what is different about it. So what I can see after working with you was this is not like an automatic tool. You cannot just buy a software, use it. It's not the only use. You're making what you're proposing. You're proposing something different. That is something tailor-made that can react very quick to a specific question that you need. We need you. Yes. We need you, and with the software we don't need you. So what is, okay, we have you, what is the pros and cons of having you? I really think that you should focus on that to explain it better. And finally, I'm just curious. I think you're a very good cook, that you have your kitchen. So someone was asking you all the processes that for us were, we couldn't see them. So for us it was very easy what you were doing, that when you were explaining that you had to make a lot of work that's from the computer science task that for you is simple, but for you, not for the rest of us. So you're like hiding your kitchen. But I just want to know what are the ingredients you use. So what were the databases and what were the more detail, what were the inputs, for example, for the mobility. Nice.
Okay, three questions. So the first one. Okay, when we begin to talk to research about urban planning and how to help urban planners to create better visualization and so on, we found some different threats. For example, one problem was to visualize the information, to visualize the for example, the buildings. So, for example, they already have automatic creation of cities, they have automatic creation of maps of the cities. And okay, we say, okay, this could be one of the topics of the research. Another one was the management of data. So, for example, in the GIS systems, we want to create some new, could be some new graphical data. But we see that in the process management, well, we already have a lot of work in PSS. That's the important part of the planning in order to create, to have, for example, artificial intelligence to make decisions or to create new trends or something like that. And we found next the new information system that it was the evolution of the CAT system. And finally, we said, okay, what if we use maybe the same ideas of the VIM of that system to create some new work. That's then we found in 2013 last year that the same idea was made in city information models. So we say, okay, how to differentiate us from the work that everybody is doing. So everybody's is taking into account one main topic and create a software tool to solve this kind of topic. For example, GIS for data management, BISIM for all the simulation of transportation. Those were white topics, and sometimes these software are very difficult to use. So they are a learning curve in order to create those. So we say, okay, we don't want that. We want to be able to answer the question from the stakeholder. So that's why we choose, okay, we're going to use task-centered analysis tools, and we read about task-centered applications, read about stakeholder, what is the stakeholder. That's why, for example, so we said, okay, we're going to use the Taylor definition of urban planning. We're going to use the Freeman and Beacon definition of the stakeholder. And some information and some ideas from Staranovsky in order to create these kind of applications. And we think, well, I think that the purpose was to create a fast application, a fast prototyping of applications centered on instance, and the objective was done. You can see it here. Well, that was the theoretical process of the work. It's because the work is new. It's not. It was not well informed in the community. We have to create this kind of information. And the second one, the third one.
The second one, what is the most important? Is why do you think that you are important?
What happened if I don't exist? Yeah, okay. Well, my idea from the beginning was to design the software, the application tool, in order to be modular. So the main work for me was the core to create this kind of applications, the core to create this kind of structure. So the idea is, in order that without me, the people can do it, I created interfaces, easy interfaces to create this kind of applications. That's why I have an XML. You use an XML file in order to say, okay, the first level is going to be from this shape, second level is going to be from this shape, and the software calculates the relations and calculate the creation part. Finally, the part of the application, the visual application, that's the point when I am most needed, because we have the visualization part from the core. I have some component that is going to be rendered, is going to be seen in the visualization, and I need to plug it in my application. So the idea is to be, like I said before, modular, in order that any software developer that knows a little bit about connecting interfaces be able to use the application. So that's why I told before that future work also is to use more users from the software point of view to create their own application. We already have some experimentation with some users.